All right, welcome to The Explainer. Let's just jump right into this because today we're breaking down the literal recipe for our amazing, one-of-a-kind home, planet Earth.
Let's start with an idea that's both super simple and honestly pretty profound. With all the incredible things we've found out there in the universe, our home is still the only place we know of so far that's inhabited by living things. This is it. This is our spot.
So that's the big question we're digging into, right? What does it take? We're going to deconstruct this recipe piece by piece and look at the very specific, absolutely crucial ingredients that have to come together to make life on Earth even possible.
So here's our game plan for this explainer. We'll kick things off with what makes Earth so unique. Then, we'll look at its perfect position in space, dive deep into its powerful core, talk about the atmosphere all around us, and, finally, see how all of that creates the beautiful colors of our world.
Okay, first things first. Let's just take a moment to appreciate how incredibly special our planet is in the grand scheme of things.
And this, right here, really puts everything into perspective. Earth isn't the biggest planet, not even close. But it has the one thing that, as far as we know, is completely non-negotiable for life: liquid water. A massive 70% of our entire world is covered in it. Just think about that.
So, how does a planet get lucky enough to have oceans of liquid water? Well, the first and maybe most important ingredient in our recipe is all about three things: location, location, location.
This huge number, 150 million kilometers, is our average distance from the sun. And that distance puts us squarely in what scientists call the Goldilocks zone. It's not too hot, not too cold, but you guessed it, just right for water to stay a liquid right on the surface.
But being the right distance isn't the whole story. This number, 23.4 degrees, is just as critical. This is the tilt of Earth's axis as it spins. And that little tilt? Well, that is the entire reason we have seasons. As we make that year-long trip around the sun, different parts of the planet get angled more directly into the sunlight, and that gives us our familiar, beautiful cycle of summer and winter. Okay, so we've got the location down, but the next ingredient in our planetary recipe isn't out there in space. Nope, it's deep, deep beneath our feet. Turns out what happens inside our planet is just as vital as where it is in the solar system.
Our planet is made of four main layers. You've got the thin crust we live on, the super thick mantle, a solid inner core, and, this is the key part for our story, a liquid outer core. You can think of it as the planet's giant, churning engine room.
Now, this swirling molten metal does two absolutely incredible things for us. First, it generates this powerful magnetic field that acts like a planetary force field, protecting us and our atmosphere from nasty solar radiation. And second, all that motion is what drives plate tectonics, that slow, constant dance of our continents.
And if you want a sense of just how powerful this internal engine is, get this. We all think of Mount Everest as the tallest mountain on Earth, right? But if you measure from its base, which is deep on the ocean floor, Hawaii's Mauna Kea is actually taller. That is the kind of power we're talking about with our planet's geology.
All right, next ingredient up in our recipe, that invisible blanket of gas that surrounds us. It's the very thing that makes life on the surface possible.
So this is the air we're all breathing right now. It's mostly nitrogen, which is pretty stable, and then, of course, that all-important 21% oxygen. Now, that tiny 1% of other gases might seem small, but it includes things like argon and carbon dioxide, which play this huge role in trapping heat and keeping our climate stable. But our atmosphere isn't just for breathing. It's our shield. It works hand in hand with the magnetic field to block dangerous radiation from the sun. And it acts like a cosmic defense system, burning up most meteors into nothing before they ever get close to the ground. So the atmosphere keeps us alive, for sure, but it also makes our world incredibly beautiful. Let's dig into the science behind the amazing colors we see in our sky every single day. It's a question every single kid asks, and you know what? The answer is just fascinating. So really, why is the sky blue? Here's how it works. Sunlight actually contains all the colors of the rainbow mixed together. As that light hits our atmosphere, the little molecules in the air act like tiny pinballs. And they are way, way better at scattering the blue light than the red light. So that blue light gets bounced around in every direction, and because it seems to be coming at us from everywhere at once, it paints the whole sky blue. Okay, so that makes sense for the blue sky, but what about sunsets? Why are they red and orange? Well, it all comes down to the sun's position.
At sunset, the sunlight has to travel through way more of the atmosphere to get to your eyes. And on that much longer journey, almost all of the blue light gets scattered away from you, leaving only those beautiful reds and oranges to make it all the way to your eyes.
And that really brings us to the main takeaway here. None of these ingredients works alone. Earth's perfect position in space, its dynamic core deep inside, and its protective atmosphere all work together in this incredibly complex system. And together, they create the beautiful, fragile masterpiece we get to call home.
The recipe for a living planet is, as we've seen, a very delicate one. All these different ingredients have to be just right, which leaves us with a final, really important question to think about. Our planet's recipe is perfect, but is it permanent?